Hi, my name's Raf. Welcome to our academy. Today we'll be doing our third video, which will be covering ratios. We covered fractions in the first one, percentages in the second one. So like I said, this is our third one now, so I'm going to crack on with it. Just in case the kids are getting a bit bored, so this is ideal for them to follow up on. Saves them getting bored because of the coronavirus, because they're indoor mostly. So let's crack on with it. So ratio, what is a ratio? What is a ratio? Ratio shows how much of one thing is compared to another. So usually it's written in the form of A and B with a dot dot. Or say with the number 1, 4, 4, 1, etc. That's what a ratio would look like. It's very, very important that the order in which it's written down, because changing the order of something, it would alter its consistency of what it is. Like, I'll give you an example. So if you were making some squash, like orange drink, so say you had a ratio of 1 to 4, that would say that the orange is 1 portion, and the water is 4 portions. That would taste quite nice. But supposing you said it's 4 to 1 instead of 1 to 4, so that would be 4 parts squash or orange and 1 part water. And that would basically wouldn't taste that nice. It'd be too sugary, because obviously 4 parts of squash and 1 part water, it would make it taste a little bit more consistent. Yeah, so that's why it's important. So ratios is something that can change, and it can make the consistency of something thicker or a different color. So if we're talking about colors, say, we could probably make a lighter purple or a darker purple, or a lighter bluish color and a different color. So it's important to get the ratios right. That's what ratios are in place for. So let's say, give you an example of, supposing you were making a cake. A small cake would be 2 to 3 ratio. So you'd put 2 parts butter. So this would be your butter, represented by, so I don't know, 6 ounces. Let's say, for example, 6 ounces of butter and 3 parts of flour. So it's 3 ounces of butter to every 1 part. Make it 6 ounces. So 3 parts are the same. 3 times 3 would be 9. So that would be 9 ounces. Yeah? So basically, if you got a 2:3 ratio, you make a cake. It would be a small cake. If you wanted to make a bigger cake, you could make that into, say, 6:9. So then you would use 2 times 6, which is 12. Or should I say 3 6s are 18. 18 ounces of butter. And then 3 times 9, 27 ounces of flour. The ratio is the same, because if you simplify this, it'll become that. But now, because the numbers are different, the cake will be a lot bigger. It will be 3 times bigger, because that's 2, this is 6. 2 multiplied by 3 is 6, and 3 multiplied by 3 is 9. So if we were to divide this by 3, so 6, 9, divided by 3, it would simplify this into 2 and 3. So that would become basically back to where we were. So proving that this ratio simplified is the same. It remains the same. It's just the number goes up because you're adding more stuff into it to make a bigger size product. Okay? Understanding that now, so if we said we wanted to make one even bigger, we could use 12 and 18. So 12, 18 is really the same ratio. And the proof would be that if we divided this by 2, this one would be 9, this one would be 6. Then we divide by 3, this one becomes 3. 9 divided by 3 is 3. And then 6 divided by 3 is 2. So it comes back to it. So although the cake here, this one would be massive, compared to this one, and compared to this one would be a bit smaller, half that size. The ratio still stays the same. Okay? So we're going on to a question now. Now that you understand what a ratio is. Let's say a purple elephant is made up of a ratio with a ratio. A ratio of two blue elephants and for every three red elephants. So basically 2 blue elephants for every 3 red elephants will make 1 bigger purple elephant. So that's your ratio. So if that's the ratio, then what's going to be the answer for this conundrum? So we have now we have 9 elephants in all. Excuse the drawing, I'm not very good at drawing elephants. At least they don't look like ducks. There you go, at last. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 elephants. Okay? And this will equal 1 big elephant. Okay? Which is going to be a purple elephant. Purple. Because really, red and blue mixed together makes like a purple, which is, we call magenta, but purple. Okay? So how many blue elephants do we need here to make this purple as a ratio, this purple big one? So it's, the question is saying the ratio is 2 blue to every 3 red. So say this is your 3 red, the first row, there's another row, there's another row. So you've got 3 rows of 3, which makes 9. So each one of these you could say pointed, 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 and then you could draw in 2 elephants each. Okay, so 2 elephants for that row. Yeah, 2 little elephants. Another 2 little elephants for that row. And another 2 little elephants for that row. So basically your answer is going to be 1, 2, 3, 4, 5, 6. 2, 4, 6. So the ratio here is 6 to 9, which basically is still If you can't see that, I'll just redraw it. 6 to 9. That's still 2 to 3. Because this divided by 3 would be 2, and this divided by 3 would be 3. So it's 2 to 3. So basically, it's the same ratio, just a different way of looking at it. So it's more elephants. So it'll be a bigger elephant. But if you look at one row, there's your 2 to 3. The other way of answering that question would be, if you wanted to answer it a different way, you could just say it's to every 3 red elephants, 2 blue elephants. Sorry, these are supposed to be blue. These are supposed to be blue. Got that mixed up a little bit. These are supposed to be red. Red. Okay. So it makes sense to you a little bit better. And there. And my red is not very good. Okay. So basically, these would have been blue elephants. I think you got the gist of it anyway, so there's your blue elephants and there's your red elephants. Because they're saying for every 3 red elephants, there's 2 blue ones. Okay? So the other way to look at it is because it's saying it's for every 3 elephants, so you'd have to divide 3 into 9. So divide the 9 by 3. It will give you the answer 3. And then because it's saying for every 2 blue, so you just times 2 by 3. So 2 by 3 will equal 6. So there'll be 6 in there. Okay? So 3 is you're going to be your multiplier then. So in other words, you've got 9 here. Yeah? So 9 divided by 3 equals 3. 3 times 2 equals 6. So you just put 6 in there. So that's another way of working it out. Many ways of working this out, but as well how you're going to understand it. So a fraction would be represented by 2 over 3. Okay. So for every 3 elephants, which are red, so that would be your red, and this would be your blue. So that would be the fraction represented for this ratio. Okay. I've said this before, but if anything that you don't understand and you've got any requests, anybody want to request for me to go over any part of this, or you got your own question to do with ratio, I can go over it one-on-one on Skype or anything like that, whatever you've got. So next part we're going to go over is how to convert ratios into fractions and percentages. Yeah? So let's put that up here. How to convert ratios into fractions, and percentage, and percentages. Yeah? So, say elephants, blue, say is 3, and say is 7 elephants, red. Okay? So you've got red elephants here, blue elephants here. So the ratio between the two is 3 to 7. So you need to make a total first. To convert this into a fraction, you need to make a total. So the total number of elephants is 3 plus 7 equals 10. So as a fraction, a portion of elephants that are blue would be represented by 3 over 10, and the portion of elephants which are red would be represented as 7 over 10. So that's what makes it a fraction. So if we was to convert that from or show a representation of what the fraction is in terms of a percentage, then we'd have to represent it as being out of a scale of 100. So what we'd have to do is we'd have to draw a scale, and we'd have to mark it 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this would be percentage, 90%, 80%, and so on. And this would be 30%. Yeah. So you can label it. This is how I would label it. And this is an easy way to work something like that out. So they're saying that 3 elephants here, here's 1, here's 2, here's 3. So there's 3 elephants stacked up already, and they're represented as blue. Okay? And then we have 7 elephants. See if I can get a better red pen, because that red pen is absolutely hopeless. I have to get a new pen. We haven't got any more reds, have we? So we have 2 reds. No? Oh, okay, we haven't got any more reds. That's strange, I'm sure we had another red. But this would be red. Okay, so I hope you can see that. You've got one, 2, 3, 4, 5, 6, 7, and 1, 2, 3 blue. So 7 red, 3 blue, exactly what it says. So all the elephants stacked up, one by one, on top of each other, would represent 100%. 10 elephants. So where the 3 of them are sitting, 3 elephants are sitting, you've got 3, which is 30%, and 7, which is 70%. So that's how you would work out the percentage. So the percentage would be like this. 30% blue elephants, and 70% red elephants. As a percentage, that's how you do it. Okay. Moving on to our last couple of things that we want to go over. It's a little bit more on that. Converting into separate ratio, fraction, and percentage. So if we add some tenths, so altogether we've got ratio, we have fraction, and we have percentage. And we have 5 tenths altogether. Okay, it's 5 tenths altogether, but 3 of them are blue. Doesn't matter what the other 2 color is, because we're not interested in the color of the other 2. We just want to make what is the ratio of the tenths relative to the blue only. So the ratio of these tenths would be, if we're judging on the blue, would be 3 to 2. Why is it 3 to 2? Because there's 3 tenths to the 2 tenths. If the 3 of them was on this side instead of this side, and these 2 were then blue and these 3 were just blank, then it would be 2 blues, 2 to 3, because 2 blues to every 3, whatever color it is. Okay, so this one hasn't got a color, so we'll just say 3 blues. So it's 3 to 2. That's how you would write that ratio. Like I said, if it was the other way around, like I'll explain it to you in a different way. There's your tenths. Like that. Okay, you still got 5 tenths. That's 5, that's 5. But now, these 2 are only coloured in, only 2 this side. So then it becomes 2 to 3. Okay? So that's getting back to what I said before about the consistency of something. So supposing you had, this was like an orange squash drink you were making. And this one would be like 3 parts of water to 2. Bit of spoons of, say, orange, and this one would be 2 parts of water to 3 of orange. So this one would be much sweeter than that one. That's why it's important, the ratio, to write it the right way. So if this is how it's drawn, 3, 2, then obviously the ratio is going to be 3 to 2. You can't write that as 2 to 3. Then it would be wrong. And fraction, the same, because it's out of 5, there's 5 there, so the fraction would be written like this. You'd write the bottom one first, which is the denominator, and you would say 5, and then you would write the numerator in, which would be 3, because it's 3 out of 5. That's how it's represented. And with percentage is going back to, you can use a scale if you want to, or you can just divide that 100 into that. So like 100 divided by 5. So 100 divided by 5 equals 20. Basically 5 20 pences at 100. And then if you times the top one by 20, it should give you 60. So the answer there would be 60%. So in other words, if the bottom one was £1, represented as £1, which is 100 pence, and then the top one would be represented as 60 pence, which is 3 times 20 pence. So that's how you would convert something which is a ratio, fraction, and percentage. It's all the same answer, but it's just different to how it's represented, where one is a ratio, one is a fraction, and one is a percentage. Okay, last one, and then we finished. So we have 6 blue swans, and another 2 swans which have no color whatsoever. So basically we need to concentrate on the blue swans, because that's what we're working with. The other 2 swans are part of the equation, but they're just there because we want to make a ratio. So basically it's saying this is part of a total, and that's what a ratio is. A ratio is a part of something. Yeah? So one part and another part makes a whole. So that's how ratios work. So like this one, we'd have to write as what would be a ratio, and then we have to work out what it would be as a fraction, and then we'd have to work out what is a percentage. And that's how we learn how to convert. So basically a ratio would be for blue, it would be 6 blue swans. So we write that down. And then 2 blank. Doesn't matter what the color is. So it's 6 to 2. But simplified, we can always simplify it by putting a line straight through here and say 3 to 1. So the ratio that I would write here, because blue is the main, would come first, because we're concentrating on the blue. This is about the blue. So it'd be 3 to 1. It wouldn't be 1 to 3. Because we're not homing in on the blank, we're homing in on the blue. The blue is the key on this. So as a fraction, then, we'd have to say 6 out of 8, but in simplified terms, we could again use the line and just say 3 out of 4, because we're concentrating on the 3. It would be 3 out of 4. So really 3/4. And everybody knows, really should know what 3/4 means. Because if you go back to my second lesson that we done yesterday, I drew that pizza, which is 25% in each, which makes 100%. So each part of that slice, each quarter is 25%. So if there's 3/4, that means there's 1, 2, 3. So 3/4 equals 50 and 25, 75%. 3/4. I hope you understand that. I think that concludes my lesson today. Thank you very much, and I hope you enjoyed it. And don't go out, stay safe. Goodbye.